right, this is our final example problem for 12.1 chi-squared goodness of fit test. So we're considering a multinomial experiment with n is 400, k is 3. The null hypothesis they give us, that the first proportion is 0.6, 0.25, 0.15. The observed frequencies are these. Specify the alternative hypothesis. So our alternative hypothesis, well, if we know all of these and they're not all the same, then we would just say that not all proportions equal their hypothesized values. Okay. B says calculate the test statistic and the p-value. So we use Excel to do that. So we can start over here. Sometimes it's helpful to label if we have anything to label. So maybe that's like a good habit to get into. All right, now remember that these are frequencies. So our observed frequencies are 250, 94, and 56. Now our expected frequencies come from the n, 400, times the probabilities, 0.6. This is what we expect to happen based on our probabilities that we've seen. Times 0.15. Okay, so now we're going to do O minus E. Drag it down. Oops, I always forget. Pause here, make sure everything's greater than 5. We're all good. We don't have to do anything like we did in the last problem. On the last video. Always want to double check that. Some funky things can happen and you just can combine like we did before. Divide by E. All right, and then our test statistic is the sum of this column. All right, and so our test statistic is our chi-squared test statistic is 1.043 or 1.04 is fine. So then our p-value, we need to find our degrees of freedom. Our degrees of freedom is equal to k minus 1. All of our categories pass the expected test. So our k is 3, so our degrees of freedom is 2. So our p-value is equal to chi-squared dist rt. So we are talking about 1.0, we could say 3, that's fine, and then 2. And we get a p-value of 0.5936. Okay, so we did that. C, at the 5% significance level, so our alpha is 0.05, what is our conclusion? Well, our p-value is greater than that. 0.5 is greater than that. So we do not reject the null, so we're keeping the null. So we can say that the hypothesized values are going to be those population proportions. We cannot conclude that at least one of those proportions is not the hypothesized value. All right, so that is how we would do that. That's it written out for you a little bit more if that's helpful. And then go ahead and give these a try. Press play when you're ready to see the solution. And that concludes 12.1.